number of questions to answer on using this graph. So this is a function. The function is defined right here, and it makes this particular graph. So the first question is, does f of negative 2 exist? So I'm going over here to negative 2, and I'm going to look and see, do I have a y value at negative 2? Yeah, I do. So f of negative 2, it does exist. Does the limit as x approaches negative 2 from the positive side, I know that might be hard for you to read, but it says x approaches negative 2 from the positive side, does it exist? Well, if I am approaching negative 2 from the positive side, does my limit exist? Sure it does. It's that point right there. It's negative 2. That's the y value of that limit right there. So yes, that limit exists. Does the limit as x approaches negative 2 from the positive side equal f of negative 2? Well, sure. What f of negative 2 is right here. It is equal to negative 2. And the limit is equal to negative 2. So yes, they are equal to one another. And since it is an endpoint, we say that then f is continuous at x equals negative 2, because it is an endpoint. Now we're switching over to positive 2. Does f of 2 exist? Well, here's x equals 2, and here's a dot right there. So yeah, sure, that exists. Does the limit as x approaches 2 of f of x exist? Well, now I want to be a little bit more careful here, right? So here's 2. I'm approaching 2 from the left, and I'm approaching 2 from the right. So if I look at what my function is doing, I'm getting very, very close to the number 1 from the left, and I'm getting very, very, very close to the number 1 from the right. So yes, the limit is the same from the left as it is from the right. So yes, that limit exists. But in fact, that limit is equal to 1. So does that limit equal f of 2? No, it does not. F of 2 is up here at 2. The limit is right here at 1. So no, it is not equal. So it is not continuous. The definition of a continuous function is that the limit as x approaches some number a of the function is equal to the value of the function at that point. So as I am approaching the number 2, my limit is 1. But my function at 2 is 2. And we all agree that 1 does not equal 2. Is my function defined at x equals 3? Well, let's erase this here. And I'm looking at f of 3, and I see an open circle here, but I don't see any points either above it or below it. And since I'm assuming that I have the whole graph, I would say no, the function is not defined at 3. So, is it continuous at x equals 3? Well, again, the limit as x approaches a, in this case 3, of the function has to be equal to the function at a. Well, there is no f of 3. It doesn't exist. So if it doesn't exist, then I certainly can't have a limit that equals it, because it doesn't exist. So if it doesn't exist, no, it can't be continuous if it doesn't exist. It's a hole, so it's not continuous. Well, what if I decided I wanted it to be continuous? I would really like it to be continuous at f of 3. So to make it continuous, I would have to say that f of 3 equals 0, because that would then fill in that point. I would have the point 3, 0. And now that graph would be continuous right there, because the limit as x approaches 3 of the function would be equal to the function at that point. This limit is equal to 0, and this value is equal to 0, so that would make it continuous. How about a value at f of 2 to make the new function continuous? Well, sure, I could do that. I could take this point right here and kind of move it to there. I'm fixing that thing. So what new value should be, so I would have f of 2 should equal 1. I should have the point 2, comma 1. And then the graph would be continuous at x equals 2. Is it possible to extend the function to be continuous at x equals 1? Is there anything I can do to remove that discontinuity? No. There is no value I can give for f of 1 that is going to make this continuous. I mean, I just made a vertical line, but then that's not a value. It's a line, and it would even cease to be a function. But if I fill in that hole, it's still not continuous. And if I fill in this hole here, it's still not continuous. It's a jump discontinuity. It is not removable. The answer is no. Is it possible to extend the function f to be continuous at x equals 4? Well, it's a little bit tricky because it kind of ends right there at x equals 4, but it ends, so that's an endpoint. So to make it continuous, all I need to do is fill in that endpoint. So if I define f of 4 equal to 0, and I have the point 0, whoops, 4, 0. Sorry, I hope I didn't make that wrong on the other ones. If I have the point 4, comma 0, then yes, then I've extended the function and I've made it continuous. Let's just make sure I didn't blow it back up here. Nope, 3, 0, I did that one right. 2, 1, I did that one right. Okay, so I did the other ones right. So yes, it is possible to make this function continuous at x equals 4.